Oh, hello, everyone, and welcome to my class. Today's topic will be about functions. So let me share my screen real quick. So can you all see my screen? Say yes in the chat if you can. Say no if you can't. Yes, very good. Okay. So this is our introduction to functions, and functions are a very big part of mathematics. So that's very important to learn, and this will start our unit on functions. All right, so our schedule today is first an introduction to functions, and finding the natural domain of a function, and then graphing functions. All right. We won't spend too much time graphing functions. We all know you can do that. It's basically just graphing different graphs, but the big idea here is to introduce you to functions and finding the domain of a function, because the domain is very important when you're graphing and working with a function. All right, so are there any questions on the schedule? Any questions? Okay, no questions. So our introduction to functions. So what is a function? A function is a correspondence from, okay, I should probably write this down. A function, why is it green? So a function is a correspondence. All right, I'm expecting you to write this down. This is quite important. And it uses a lot of big words, so if you use this in your writing, you will sound very professional. So that's why I'm using it. Is a correspondence F from a set D to a set E such that to each X that is part of the set D, there is a unique associated Y in E. All right. A function is a corresponds F from a set D to a set E, such that to each X in the set D there is a unique associated Y in set E. Okay. Are there any questions on this definition? I'll explain it later. And no questions. Okay, I should probably wait for you to type down your answers or type down your questions. No, so still no questions. Okay, great. So, um, what's the meaning of this definition? So it's best that I draw you a little graph here or a little picture. All right, so these two circles, this represents set D. Okay, and this represents set E. All right. And for each X in D, there's a special Y in E. Okay? So that means that F is the correspondence between a set D to a set E. Okay? So that is what a function is. And I said here, it is very important to note that f of x, which is our function, can assign more than one x to the same y, but not vice versa. So how does this work? Okay. So let's redraw this. We can have another one here. Let's call this, hold on. We have our set D, and let's say we have two x's. Let's call them x1 and xy. I know. I mean, no, x1 and x2. I know. Very, very, very original, you know. Okay, so x2 also corresponds to xy. I mean, y, and x1 also corresponds to y. So they can both correspond to the same y, but not vice versa. So how does this work? This means that x1 cannot have y1 and y2 corresponding to it. Okay, so let's say, let me draw you a graph again. So if 1x has, let's say this is x1, 0, or x1, y1, and this is also, this also has the coordinate x1 and then, but y2, here they form a vertical line, and that's not allowed in a function. However, a horizontal line is allowed. Okay, this is possible. Okay, we can have x1, y1, and then we can also have x2. Oh no, never mind. Yeah, x2 and y2. So this, cross out this, and we can have this horizontal line right here. You see that they have different x's corresponding to the same y, and that's allowed in a function. But this a vertical line, if you see a vertical line in a function, that's not allowed. But if you see a horizontal line, then that is allowed. Okay, so are there any questions about functions? Any questions? If you have any questions, feel free to give me any questions. I will make sure to answer them probably. All right. So let's continue. Let's complete some warm-up exercises first. So I'll give you a couple warm-ups to see if you have a good understanding of functions. Okay, so our warm-up is, let's say we have, I'm making this up on the spot, so be patient. X, y, we have 1 to 0. Okay, this is f of x. Okay, this is f of x. We have a function here. We have 1 to 0, 2 to 0, 3 to 1, 1 to, oh, nope. And, okay. We have 3 to 2, and 1 to 4. Okay, so is this a function or not? Okay, this is our warm-up. Should be pretty easy if you understand the definition of a function. Is this a function or not? Type your answers in the chat. Okay, is this a function? Yeah, that is not possible. It is not a function. Okay, very good, Stephen. It is not a function. Why? Because, you see here, there are two x's. I mean, the same x's. That same x that corresponds to two y's, and that's not possible if you recall the definition. So that is not a function. All right, let's move on. So domain and range. What is the domain and range? You need the domain and range. They're very important factors when you're graphing graphing a function, okay? Especially domain, okay? So what is the domain? So these are our two big ideas here. D is the domain of F, okay? D is the domain of F, all right? So you see this set here? Any X in D is part of the domain. So D is in the domain of F. The range, okay, we need to, let's say we have R, okay? Let R equal Y is a part of E and Y equals Fx, okay? For some, it has to be corresponding to some X that is part of D, okay? Then R is the range of F. Okay, so that is the domain and range. All right. So let's do some. Let's do some exercises. Okay. So um, let's see what's the next. Okay. So let's do some exercises. Basically, the domain, since D is the domain of F, then that means D is all the possible X values, right? So that's very important. Let me see. All possible X values. All right, all possible X values. And then what is this? Okay, range. And if domain is all possible X values, then range would be all possible Y values. So make sure you have this in your notes. All right. Why can't I draw straight lines? It's ironic. All right. So let's say we have our function F here. Don't mind the bad graph. This is very easy exercise. I'm just testing you if you understand what domain and range are, okay? So don't, you should get this, all right? You should get this if you understand what I've been teaching so far, and you should if you have been listening. Okay, and let's see here. We'll put it here. All right. So, what is the domain and range of this function? What is the domain and range? Okay. The domain, what is the range? Okay. What is it? Oh, and I also want you to note when it is decreasing. Okay, and when is F increasing, decreasing or constant. Okay. When it is increasing, decreasing, or constant. All right. So I'll give you a few moments to do this. I'll fix up some of the lines here. All right. So this should be pretty easy. And I'll check back in a couple moments to check your answers. All right. Are there any answers? Any answers? What is the domain and range of this function, and when is it increasing, decreasing, or constant? Are there any answers? I don't see any answers, so are there any questions then? Steven, do you know the answer? Steven. Should be quite easy. Does nobody know this? Show the question. I've been showing the question all along, Edward. Oh, and this won't be in one interval, okay? This won't be in one interval. Let me give you a hint. It's in 3 intervals. Well, at least the domain is in 3 intervals. Okay, so the domain is -3 to 0. Let's see. Okay, and 1 to 2, and 3 to 5. Okay, very good. Let's see. Negative. Yeah, that is correct. Very good. And the range is -1 to 1, 3 to 5. Okay. First of all, I don't think it's. Are you sure it's 3 to 5? Pretty sure the range is 2 to 4, but it's fine. As long as you get the main idea. But the range, I would like to raise a question, all right? That might change your answer, all right? So, you see this interval here? It is from -1 to 1, right? But, there's also a point at y equals 0 that is not included, okay, in this interval. So do we change our answer or not? All right. Do we change our answer or not? The answer is no, we don't change our answer because we still have this point here is also y equals 0, and that is included, so in the range, so we don't change our answer. So very good job, whoever who said that range, yeah. Good job. Okay, so that took way too long. So how to find the natural domain of function? Let's move on. This should be a bit harder. Okay, so our example here is if f of x equals the square root of 4 minus x squared over 1 plus x, find the natural domain of f. How do we find this? Okay. See, the domain is very, very restricting, okay? The domain f of x must be defined, right? Okay, so f of x must be defined. So that means our natural domain is like usually, let's say, if we had a function like this, okay, y equals x squared, that's an all real function. Everything works on it. It's always defined. But if we have a function like this, f of x equals square root of 4 minus x squared over 1 plus x, we have this, but it's not always defined. And the domain is when it is defined. Because if x is in a place, on a point where it isn't defined, then that's a problem, right? So to find our natural domain, what we need to do is, are there any suggestions first? Okay, yes. Oh, very good, very good. That's great. So, you're already a step ahead of me. So, the natural domain, the domain of f, equals x is a part is in the set R, which means it's a real number, right? We can't have I in here mingling with these real numbers, okay? It has to be defined because I is an imaginary number yet, right here, so we can't use that. And what we need to do is, how do we find if it's how does this function? When is this function undefined? All right, we need to find that first. There's a lot of situations where it is defined, so we have to find where it isn't defined, where it's undefined. All right. So you can see here there are two key situations where it's undefined. All right. So when we have 4 minus x squared over 0, then that's undefined. Okay. And then when we have square root of a negative number, let's say negative n, okay, and assuming n is positive, I mean just positive, okay, assuming n is positive, okay, assuming n is positive, then square root of negative n over 1 plus x, okay, that's going to be bad, right? It's also no solution because we can't have a square root of a negative number, so that is what we need to avoid here. All right, so the next part of our statement is that x does not equal negative 1, because if negative 1 plus x, that's going to be 4 minus x, the square root of 4 minus x squared over 0, right? We can't have that. And then we also need 4 minus x squared to be positive. All right? And it has to be positive, because it's in a square root and we can't have a negative number in a square root, right? So let's continue. What we need here is we need to solve for this, right? We need to solve it. And there are two ways to solve it. I suggest the first method. Okay, so here's the first method. Who knows how to do the first method? So basically, it's so easy, right? We've learned this before. It should be pretty natural now. Okay, so what you need to do is you need to move the x squared to the other side. Get 4 here, okay? X squared is less than 4, okay? Well, less than or equal to 0, okay? Less than or greater than or equal to 0, okay? 4 minus x squared is greater than or equal to 0 because 0 still works, right? Okay, so 0 still works, all right? So after we have this, you see the square here? We don't like squares. You can do this, square root it, okay? It's very easy. You get, oh, we have a problem here. I don't think, have I taught you this before? I don't know if I've taught you before. I might have mentioned it somewhere around here. But who knows the square root of x squared is? Who knows what the square root of x squared is? Okay, what is the square root? Yes, this is what we need. The absolute value of x. All right, this is the absolute value of x. Okay, so if, let me give an example. If x equals 5, then x equals plus minus 5, right? The same thing, but you can't say that the square root of x squared equals plus minus x. That's not good, because even though it really doesn't matter, kind of, in a linear equation, well, sometimes it does matter, but in an inequality, that's very important. You need to know whether it's absolute value or not absolute value. So the absolute value of x is less than or equal to 2. All right. And you can see here, we get the interval -2 to 2. But don't forget this. X cannot be equal to -1, meaning the domain is -2 to 1, union 1 to 2. Okay, are there any questions about finding the natural domain of f? This is our solution here. Any questions? If there are no questions, then I will move on. All right, so let's do a similar example. All right, this is a very similar example of our last example. Okay, similar problem. So I would like you to do this. All right, remember the two cases where where f is undefined, because there are two cases where f is undefined here, and make sure to exclude them from the domain. All right, I'll give you some time to work. I'll check back in a couple moments. All right, so are there any answers? We have two comments. Okay. Edward, you say it's -1. What do you mean by it's -1? Please elaborate. And then our other answer is x is greater than or equal to -1/2, and x does not equal 3. I see. Oh, yes. That was the last question. Yeah. Wait, what? Oh, I see. I messed up here. Thank you for reminding me. It's 2 to -1 and -1 to 2. Yes. Thank you, Edward. Sorry for the mistake I made, errors. Okay, so how are we going to do this? Can anybody help me with this? What do we need to do first, okay, to find the domain of f, right? What does it need to be, okay? X is All right. What are our two cases? Okay, name the two cases where f is undefined. Okay, what are the two cases? All right, we can see one clearly here when the denominator is equal to 0, so we can't have that, and so that means we can't equal. X does not equal 3. All right, and 2x plus 1 is greater than or equal to 0. So what do you need to do here? You need to solve this and to find an interval. Okay, an interval. So 2x plus 1 is greater than or equal to 0. This is a very easy inequality. Okay, so this is what you get. So what you get is this interval. All right. So you must not forget this. Okay, it's going to be -1/2 to 3 union 3 to infinity. All right. So I'll wait if you have any questions. So do you have any questions? What questions do you have? Okay, are there any questions? All right, yes. Yeah. Okay, yes. Two cases for which is undefined or imaginary number. Very good, very good. So let's continue. Next example. This is our second example. All right. So please do this. All right. So any answers yet? All right. So x does not equal 2 or -3, and x does not equal 0. All right. Very good. So how are we going to do this? Okay, how are we going to do this? So basically, we need our statement here. Domain of f equals x is a part of set R. All right, so what we need to do here is that x is greater than or equal to 0. That's the easiest thing we can do. And then x minus 2, x plus 3. All right, and that is not equal to 0. And since not equal to is very, very similar to equal to, you can solve it just like you would to a normal equation. All right, normal equation. Okay, and since this looks like a factor form of quadratic, you can do the same thing as a quadratic. So it does not equal, x does not equal 2, and it does not equal -3. All right, so from here you get the domain 0 to infinity. Okay, and you can see that it does not equal 2, so And -3 can kind of cancel out because it's not in there anyways, right? -3 is less than 0, so you can't have that in there. So you get 0 to 2 union 2 to infinity. Okay, so like this. Any questions? No questions? Then I will move on. All right, please do this one. So no question, no answers yet. All right. Or maybe I gave you like 5 seconds of time, but okay. I'll give you another 5 seconds of time. 1, 2, 3, 4, 5. Okay, just kidding. This should be a pretty long question compared to the other ones. And remember to use the sign chart when you are solving. Okay, remember to use the sign chart. All right, because of these quadratic inequalities, very troublesome, you know. Are there any answers yet? No answers. All right. Okay, I'll give you a bit more time to do this. Oh, we have an answer. You think maybe. You think maybe. You think so. Oh, okay. All right. Let's see if you're correct or not. But first, are there any other answers besides that? Oh, yikes, you got it incorrect. Oh, yeah, you got it incorrect. I think so, yeah. You selected the wrong. Oh. Remember, it's greater than or equal to 0. So it's you have 5 intervals, right? So select the intervals that are not what you picked. It should be 3 of them. If you understand. I think this is where you made your mistake. You thought it was supposed to be negative, it's supposed to be positive. Okay. Maybe. I don't know if you understood what I said. You understand when I get there. All right, but who gave me the answer that was wrong, please pay attention on how I do the sign chart. All right, do not split the square root up, okay? Do not split it up. It's better if you do it all together. You should do it all together. It's easier. Okay. So you get 2 minus x, 2 plus x, over 3 plus x, 5 minus x, and that should be all equal to 0, right? It's all in a square root, should be positive, or equal to 0, right? And when does x equal, when is x a 0? We need to exclude the 0, right? So create your sign chart here. It's our solution. This is our solution. So basically create a sign chart. All right, so we have intervals -infinity to -3, -3 to -2, -2 to 2, 2 to 5, 5 to infinity. All right, those are our intervals. 2 minus x, 2 plus x, 3 plus x, 5 plus minus x. All right, so see here? Now you're going to see if they're all okay. Right, should be normal for you guys. Okay, I just taught this, the quality sign chart, right? Should be pretty easy. You see where you made your mistake? Because your answer was exactly the opposite of what it should be. All right. You chose these two. We're trying to be positive here, okay? Not negative. So we need to choose these three, which is exactly the opposite of what you chose. So our answer, you got really close. You literally did it correctly until the last step. You chose incorrectly. So make sure you check your answer. So our solution would be -infinity to -3, union -2 to 2. And see here, why is 3 not included? Because it's in the denominator, right? Even if it's greater than or equal to 0, can't be -3. Okay, that would result in a denominator that's 0. Can't do that, right? Never mind. This 2 you can have, okay. And the last one is 5 to infinity. All right, so do you understand your mistake now? Yeah, you reversed it. Okay. So graphs of functions. All right, let's look at some graphs of functions. All right, graphs of functions. And we have our last quite hard example here, maybe. Okay. So graphs of functions, what you need to do is you just need to graph them. It's that easy. Just graph them. Okay? Why? Because functions are basically the same as equations. You just have to graph them. Okay? So we have f of x here. The graph of f of x would be equal to y equals f of x. You see? So you can just graph it. What you get? Y equals x cubed. The graph looks like this. Maybe not. Okay, you just graph regularly. Okay, with functions, you just graph regularly, and it turns out to be this. All right, so there's nothing fancy in graphing functions. All right, but you must use you must make sure it's defined, right? You have to find the domain in the range. Okay, that's the big part. So there's nothing much for this slide. Let's get on to examples. You should understand more when you get to examples. All right, so find the graph of f of x equals x squared and g of x equals square root of x. All right, this is very easy, right? Very easy. what you need to do is you just need to graph it. Substitute f of x for y. Y equals to x squared. You know that, right? Parabola. G equals x. Y equals square root of x. Exponential function like this. See? Very easy. So there's nothing fancy in graphing functions. All right, so now, can anybody tell me the domain and the range of these two functions? What are the domain and the range? The domain and the range, all right? The domain and the range of these two, well, let's split it up, okay? It's the domain of, okay, so this is for function f, right? For function f, what is the domain and the range? For function g, what is the domain and the range, right? Should be easy enough, right? So the domain of function f would be just in infinity, negative infinity to infinity, right? Be negative infinity to infinity. And the range would be 0 to infinity. Well, 0 is inclusive. All right. Domain here is, again, inclusive 0 to infinity, and range is also inclusive 0 to infinity. All right. So you can see here that whenever you have a 0 to infinity, both times it's in the first quadrant. Whenever you have the domain that is negative infinity and infinity, and you have range 0 to infinity, it's in the first and second. If you have negative infinity is 0, it's in quadrants 3 and 4. So you can kind of see this. All right. So are there any questions about this example? Should not be a very hard example, okay? But the next one you're doing is yes. The next one we're doing should be even a bit more challenging. All right. So if f of x equals negative square root of 36 minus x squared, A graph y equals f of x. B, find the domain and range of f, and C, find where f is increasing, decreasing, constant. See what I mean? Should be a bit more challenging. But first, let me refresh on what this function f is. All right, what is this function f? If you recall from our lesson about Euclidean geometry and circles, you know that this is an equation of a circle, but which half? Which half is it? This is the bottom half of a circle, okay? This is a bottom half of a circle, all right? Please excuse me while I'm trying to draw a circle. It's very hard. Oh, there we go. Okay, so our center HK here in a point XY, right? This is C, this is P, XY, all right. And this, what is this? This is R, okay? So basically the area, this distance formula is basically the distance between C and P. All right, so if you get this, you get x minus h squared plus y minus k squared equals r squared, right? And then what you get y minus k squared equals r squared minus x minus h squared. And then what you need to find out is since this is a bottom half of a circle, which means that y minus k is going to be the absolute value of that would be negative y minus k. So square root gets absolute value of y minus k. It's going to be negative y minus k, which is k minus y. Okay. What you get here is you get y equals k minus square root of r squared minus x minus h squared. All right. So that is the equation of the lower half of the circle, right? You can see here it's exactly in the format. So that is lower half of a circle. Now that we know this is a lower half circle, I hope you can do it by yourself now. Actually, we're running out of time, so let's not do it by ourselves. It takes too long. All right, so any questions yet? Oh, of course you wrote them already. Well, I guess the domain is kind of, yeah. Yes, I know. Being very fast, you know. So if you graph this, you know that 36 is r squared. 36 r squared, then r equals 6 in the center. What is that? The center equals 0, 0, right? Great. Now we can graph. Lower half circle, center 0, 0, bam. Wow, that's that's really bad. Okay, hold on. Bam. Nope. Bam. No, still not doing it. Okay, last one. Bam. Acceptable. Though it does have a dent here. Let's fix it. Kind of. Let's fix it. We made it worse. All right, let's not talk about that. And so you can see here that the domain here is going to be -6 to 6. Range here is going to be -6 to 0. Oh, what happened here? Oh. And I took a screenshot on accident. Great. So you can see that's the domain and the range, and when it is increasing. Increasing. Zero to 6, right? Here you increase to here. When is it decrease? Decrease, decrease to here. So basically opposite of that would be -6 to 0. And of course, when it's constant, there is no point where it's constant, so that would be no solution. All right, so are there any questions on this? Any questions? Yep. Okay. All right. So that was our last question. So thank you for listening. If you have no questions, you can leave now. All right. Thank you, everyone, for joining my class. I'll see you next time. How do I stop this recording? How? Oh, you just press stop. Okay. Anyways.